Welcome everyone, my name is Luca and this is my good friend Marco.
Hey, welcome! You are about to form a new random access memory. Before to start the podcast, please remember to share this video with people who love to think about science and technology.
And think about hitting the subscribe button to be updated with new and exciting memories. And today's memory is about, are we ready to become space citizens? What's your take on it?
Well, there is a 400 metric ton, which I don't know how much it is in an imperial system, but it's a very, very heavy building that is zipping over our head right now at 27,000 kilometers per hour, which is about 2 orders of magnitude higher than a bullet. This looks like we are about to become a spacefaring civilization. And today, I exactly would like to talk about this. Are we becoming interplanetary? Are we at the dawn of a new age of space travel? There are many clues in the technological development that seems to suggest so. At least because it's not a long time since we first sent the first man-made object into space. Actually, there is a little bit of debate on this, but basically it happened between 1944 and 1949. And actually, in 1944, it was a rocket sent to space by Nazi Germany, because basically they wanted to send a rocket and hit London directly from Germany. And this rocket went somewhere above 300 kilometers above Earth's surface, and by some is considered space. But actually, according to NASA, the first ever man-made object into space was a bumper rocket. It's like the first line of rockets from the US, which started in 1949 for a scientific research. It was a modified version of the German rocket from before, which was called the V2 rocket.
So are you saying that a USA built institute believes that a USA rocket was the first one? That's what you're trying to say. Interesting.
Yeah,
that's an interesting point of view. But no, yeah, the one thing that I want to say is how bad of an aim the Germans had with that fucking rocket.
To miss London.
It's not like a little city, come on.
Yeah, we also have to think that back in the day it was probably smaller. I think that Milan, actually if you look at the Chinese and Indian city, they tend to be very small. Like in the 80s, I think Shanghai was smaller than Milan, for example, and now it's
as a size, not as a density, potentially.
No, in terms of population, actually.
Oh, okay.
But yeah, we are going off on a tangent. Back to space, pun intended. Back to space. Another very important aspect that I would like to talk, that it's relevant when we think if we are becoming spacefaring or not, is the overview effect. Do you know what it is?
Actually, I don't think so. So you can maybe explain it to me in a very 5 years old kind of way.
Okay, so the overview effect is when you go to space, which I'm sure you already did.
Yeah, like yesterday.
Yeah, me too, in my dreams. But when you go to space and you look back at Earth, you usually have a cognitive shift. So you start to see the Earth, like when you have the whole Earth or a portion of the Earth in your view field, and it looks like a blue marble with all the clouds and the ocean, and you suddenly realize that all the people you know, all the animal, everything, it's just a very, very, very thin film around this sphere. You understand how fragile and how important it is. And this cognitive shift was described firstly by the Apollo astronauts during the first voyage to the moon. And even though I guess it happens with a smaller intensity, also many astronauts on the International Space Station report this feeling.
So it's what would be called changing perspective on how you measure as opposed to how you think you measure. As in, a city is big, but is not as big if you think about it in a state level. But a state level is not as big if you think about it on a continent level. So when you look at a planet and you are on it, you have a perspective. But when you look at the planet itself from another perspective outside of it, your perspective changes. That's more or less what you're trying to say, right?
Yeah, it's like you understand that we are all connected, that we all depend on a really small and thin and fragile things. And basically, like all the astronauts who report this overview effect, suddenly when they come back, they become very active in environmental activism. So they really have a cognitive shift, and they talk about this, and it's really fascinating because we live in a world where the cost of space travel is dropping. I mean, it's prohibitively high, but if you compare the number of people who have been into space today, comparing to the number, let's say 20 years ago, during the space shuttle era, for example, of course, the number now it's much higher, and we have a continuous presence in space, which we didn't have previously. So I think that the number of people who undergo this cognitive shift will increase, and the good news is that if you have the overview effect, you understand the importance of space exploration. So you understand the importance of becoming a multiplanetary species.
To be fair, I have two things to say that they were in my mind as of now. First, I think Greta Thunberg comes from space because she has this overview effect already inside of her, I think. And the other one is, I'm speaking for myself, but I do understand the importance of space travel and space exploration and whatever in relation to humankind, because more recently I've been made aware that we have just one Earth and we are very good at destroying it. So I don't know if you know that there is a date in time every year when we expire the resources available for us on Earth for that year. During the 60s, it was around October. Recently, like last year, it was around the end of May, first days of June. After that one, we are using 2 Earths of resources to survive. So yes, I do know that we either need to improve how we use resources and how we are as a human species, which we can do because, innate shit and whatever, or we destroy something else and then move on and whatever.
But I would argue that also for that, space travel is absolutely important, because if we unfortunately make our world less habitable, then we will really benefit of the technologies that would make other places habitable, like better
terraforming, basically. Or actually, there is another point here. I don't want to go too far away, but we as an entity have a specific set of requirements to be able to live. So travel or exploring is good, but how much do we need before we reach a place where we are compatible to establish something there? Also, to create something, to build something, you need to move people and resources as well. And unless you have a very, very fast way of travel, Sci-Fi would say, yeah, you're faster than light travel and whatever. Unless we have something very fast, it's not easily be doable in a short period of time. So what I'm saying is, we would need to start planning our oh shit moment now, not when we are able to reach the place, because when we do it, it's going to be too late for a lot of things already. Also, another question that I have for you: with this COVID, problem, whatever, it has been made aware that a lot of things are not for poor people, and a lot of things are for rich people. So how is it gonna be for space rights? As in, only the rich people are gonna have the ability to save their assets, or is it gonna be a mankind adventure also as well? We are so much divided that I think to be able to go to space, we should be more of a humankind idea as opposed to US space program, China space program, European space program, and so forth and so forth.
Yeah, there is quite a lot to unpack. I will start from the technology. My idea is that we need an infrastructure to become a multiplanetary civilization. So we cannot become a multiplanetary with the rockets we have now. So the rockets we have now are starting to become way better than the first rockets, like the rockets of the Apollo era. I mean, right now they are much less powerful, because if you think about the Saturn V, which was the rocket that brought the astronaut to the moon, it was way more powerful than even Falcon Heavy. You know, it was a seriously powerful rocket, and we don't have anything like that until there is the spaceship from. There is the spaceship, or I think also NASA is trying now to create a modified version of the Saturn V. But anyway, I mean, in terms of power, they had the upper end. But nowadays we have rockets that can be reused, and the cost of sending a kilogram of stuff into low Earth orbit or in geostationary orbit has dropped in an exponential way, and it will continue to do so. And there are some technologies potentially in the future that might really bring down the cost of space in a big way.
So basically what you're saying is, what I believe as well is, the more something evolves, the more it becomes commercial, so the less it costs to be able to do something. So, okay, then I'll let you go again, but you're saying that in our lifetime, we should be able to see enough commercialization of space travel to be able to do it even for normal people?
Well, no, this seems a little bit optimistic. What I hope to see in my lifetime is to start to see at least a colony on the moon, which will probably not be commercial, I guess. I guess it's too early for that, but at least a scientific colony on the moon, something like the science base that we have in the South Pole, something similar on the moon. So a scientific, like the International Space Station, but on the moon, and possibly a bit larger and with some degree of self-sufficiency. So with some degree of mining, for example, mining of water from the ice that were found in 2008. And one other thing that I really hope to start to see is the asteroid mining. Actually, asteroid mining sounds really science fiction, but it's not necessarily so. I mean, if you are thinking about the asteroids in the asteroid belt, well, it might be hard to bring back stuff from there. But if you think about the asteroids that are coming closer to the Earth, we could, with a relatively low acceleration, we could bring them in a safe orbit around the Earth or the Moon, and we could basically exploit the material from that. And
so, continuing on what I was telling before, what's your feeling on the validity of space exploration, travel, whatever you can think of, in relation to wealth and money?
Well, right now we have just a bunch of government organisms which are able to afford space travel, and right now it's let's say most of it it's for scientific purpose, even though we have a good bunch of telecommunication satellites that are commercial. And if you think about these, like even, okay, the GPS I think was initially made for military purpose, but actually the telecommunication satellites were, I have to say, I don't know when they started, but the sheer scale of the number of satellites that we sent in orbit in the last 10 years, it's just out of scale compared.
Some people have a little problem with Elon Musk because the sky is not as clear as it was before during night because of all the things that were launched in the last decade or less. So I totally get what you're saying. Also,
yeah, there is also another little problem, very little problem, that there was a couple of years ago, there was a modern telecommunication satellite which hit a very old Soviet scientific satellite, something
Always
on
the
the
Russian,
scale.
always the
Yeah.
Russian.
It was an abandoned, very old, very heavy, something like 4 ton, like giant Soviet old satellite. And they basically smashed into pieces, and I don't know how many hundreds of thousands of bolts and small pieces of paint and metal went out from that explosion, but a lot. And
but they were kind of taken care of by the atmosphere falling down, so yeah.
not really, because they are still, I mean, some of them probably went down, some of them went up, so they went somewhere in the outer solar system, but a large chunk of them, it's now a cloud of debris around the Earth. And if this debris becomes too dense, basically what happens is that it will become more difficult to maneuver other asteroids, and it could happen like a domino effect, that new asteroid will smash into each other, basically
So,
bringing back to before the 60s. Like, we will not have the possibility to send stuff into space anymore.
I see. So not only we pollute the Earth, we also pollute the sky. I see. That's how humankind works. No, but I think the removal of such thing is expensive as fuck. So that's why we don't really remove it as of now.
We do. Actually, the Starlink program, I don't know exactly if they are programmed to fall back on Earth or to fly away into the outer solar system, but actually they are designed that at the end of their lifetime they will find their own demise. Let's say they will not become space junk.
Okay, so that's nice to know. But what's the last thing I want to say before we move to your other questions? I think was and the concept of unity for space X, with X being survival, whatever, as a unified country. Think about Star Trek or Star Wars, whatever, where you have a federation of planets and the planet itself is united. So do you think the unity of humankind is needed for saving ourselves and explore space, or you think we can still be fractured and effective?
Well, I think if we bring down the cost of sending humans and infrastructure into space, or on mining material and directly build the infrastructure directly in space, I don't think we really need to be united. So I think that, of course, we need to cooperate. Of course, we need to avoid war, but so we need it on Earth. If you think right now on Earth, there are hundreds of countries here on Earth, and we only have
195 are the big ones.
Okay, so yeah, so probably it's an accurate number, but let's say more than 100 countries on this single planet. So imagine a future in which we will be several billion, maybe we will be numbering in the tens, if not hundreds of billions, and we will be in different planets, in artificial habitat in the solar system. So I think we will probably be in the thousands of states and organizations, and it will be fine. I mean, as long as there is no war, and as long as there is a cooperation, like scientific and commercial exchange between these entities, I don't think that having multiple entities it's a bad thing per se. I tend to be more scared to having a single government, because it's kind of difficult to hold them accountable, you know?
Yeah, that's another interesting aspect. I would say you had another point that you wanted to talk about, right? I seem to remember.
Yeah, actually, you asked me what about the infrastructure and the technology that will enable us into space. And well, I think, of course, the reusable rocket, it's a good start, but the rocket, as you know, it's very ineffective, because it needs fuel to go up, but it also needs more fuel to carry the fuel. So the bigger rockets, to make it more powerful, the heavier, and it's basically always expensive. So you need like the key technologies that you need is to have an infrastructure into space where you can directly mine things from space, and here comes the asteroid mining. But you also need, of course, a reason to be into space, which would be space manufacturing. And you might also have an infrastructure to avoid the gravity well of Earth. Do you know what is a space elevator, for example?
An elevator that goes into space?
Yes, that's correct. So basically, the idea of the space elevator, it's like, okay, imagine an object in geostationary orbit. Okay, this object looks still compared to the Earth. So it's like it seems it's not moving because it's rotating
relatively stable. Yeah.
Exactly, like it's rotating around the Earth at the same rotation speed of the Earth. So it looks like flying in a spot without moving from Earth. So if you put something that has the same rotation, but it's further from the Earth, so the gravity attraction would be lower, and the linear speed would be higher. So this object will basically fly away. So it's basically pulling away from Earth. So if you attach a string to that object, the string will be pulled and will be in tension. And this is the basics of the space elevator.
So
and,
you would then use the cable as the base for moving things up and down. Okay, I see your point, yeah.
You will take something that climbs over this cable, and finally when you arrive to the top, a little bit before the top, because as we said, the top is above geostationary orbit, but when you arrive at geostationary orbit, you already have the linear speed to be into orbit, and that would be extremely cheap. And there are a couple of ideas for this. Like basically there are only two known materials with which we would be able to design a similar structure, which is Kevlar and carbon nanotubes. And the problem of Kevlar is that it's not nearly strong enough. It's really, really weak. So,
which is interesting because it's being used as a way to avoid bullets and as one of the most resilient materials we have. But yeah, I digress.
Yeah, I mean, it's very strong as a material. For example, you could not do a space elevator with steel. Like steel will simply break. Kevlar, you can think to do it, but the problem is that on Earth, it would be very wide. So it's like the cable, the cable will start thin, but the more you come closer to Earth, the more it becomes wide. Why? Because the tensile stress becomes very strong. So basically it will be extremely wide at the basis.
Okay, so it would be distributed to the base and then thinner and thinner and more compact the more you get up. Yeah, that wouldn't be a cool elevator. Yeah, I see your dilemma here.
But if you are able to produce on a larger enough scale the carbon nanotubes, you will have that the base of the elevator would be around twice the diameter of the tip. So it's like with the carbon nanotubes, you really nail it. The point is that I think we don't still have the ability to produce carbon nanotubes on that scale and to do structure on that scale with carbon nanotubes, unfortunately.
So we should be able to see, talking about our lifetimes, we should be able to see at least this concept being a reality. I don't think we are that far away from being able to produce those materials in a big way. So maybe we are going to be able to see that. And then when we are dust and whatever, there's going to be, teleportation. So that would be useless.
Well, I have to confess that I don't know so much about the research about carbon nanotubes. Quite frankly, it seems a little bit optimistic to imagine that we will have a space elevator in our lifetime. Also because it seems expensive to build. Like, even if you have the technology to build it, it's not really obvious that you want to build it. I give you a very simple example. Like the railroads were existing since the beginning of the 19th century, but only at the end of the 19th century you had a railroad that went from East Coast to West Coast US. Because before that, you didn't have the number of people and the number of commercial freight that are useful for such an infrastructure to be built, let's say.
On the other hand, you have one of the famous quotes from Ford, the automobile creator in the US, that used to say, if I gave people what they wanted, they would still use horses and carriages. So on one hand, you need to wait for the market for it. On the other hand, sometimes you need to force the market to exist.
Yeah, actually, I think it's a push and pull. It's a push and pull approach. So I think the pull will come, of course, from the space manufacturing, which is interesting because you can manufacture determinate protein and determinate compounds, chemical compounds at low G environment, which is definitely interesting. And also because you can, for example, use thermonuclear plants. If you put a thermonuclear plant on the moon, it's no problem, because even if it goes Chernobyl, there is not much environment to pollute there. Same goes in outer space. And on the moon, you can even put some factories or some bases close to the poles of the moon. And given the low gravity, you can build a structure to have solar power 24/7, let's say. So it's very interesting for a large array of manufacturing. And of course, the asteroid mining will be a major industry, because you have asteroids, for example, with cobalt, with gold, and there are at least 12 which are called ERO, so easy recovery object. So objects that fly close to the Earth and that are not too heavy and are very easy to scoop in our area of influence, and full of gold and cobalt.
That sounds interesting. And as a last question, actually, it's a two-sided question, but the scope is kind of the same. So you now realize that the majority of advancements that we have in space travels are private companies. You have Elon Musk, you have Bezos from Amazon doing stuff, you have Virgin Creator doing some stuff, and it's private. So I remember reading a quote from space astronauts that were saying that privatizing travel in space is bad and it shouldn't be allowed. And I think Elon Musk was very, very hurt by this, because he was looking at Amsterdam and whatever as inspiration for that. And that's my question. So what do you think about this? And the other question is a little more down to earth. If we reach space collaboratively, how do we deal with ownership? Because the USA tends to be kind of possessive of everything that they put their eyes on. So those two questions are the remarking closing ones that I want your opinion on.
Well, I think that in my opinion, privatizing space, it's a very positive development instead, because actually you untap some potential. Like when you have governments and state organizations, let's say, you have a strong will and you have a strong financial power, but you have few actors. Like we already said, like 190 or few countries all in all, and also you don't have competition, which tends to be like, usually the competition tends to be positive for technology. So I'm a fan of private space exploration, because I think it has a good potential both for technological development and also for, let's say, democratization of space. Of course, for now, only few billionaires are able to afford a space journey. But by the time that we die, hopefully, if we live long enough, we will see millionaires and then just wealthy individual being able to afford such things, and soon after we die, there will probably start to be point-to-point space travel in a quite widespread way, and you will start to have a consistent human presence in the space. So I think it's slowly becoming more affordable. Of course, if everything goes well, if we don't go extinct, if we don't nuke ourselves, and so on. And for what concerns instead the ownership of space, I think that as things stand now, we don't have the power to claim any ownership. I mean, the astronauts of the Apollo era put an American flag on the moon, okay? Now we are in a context in which even if you want to just remove that flag, you cannot do it, because the closest man on the moon projects are in the 2030s. So we are in a condition in which we cannot own space. So I have the sensation that whoever has the capability to own something will just own it. And I don't see this as very problematic, because I expect that there is really few stuff in space right now. Even if there is life on Mars or on some other satellites of large planets, I don't expect this life to be so advanced that we actually lose something. Like I prefer to have a Mars colony than to have a population of a few bacteria per cubic meter in the subsurface of Mars, let's say. Of course, it will be interesting to study. Of course, we need to preserve it, but we can own the planet of Mars if we have the ability to do so. So it's time to say goodbye. Thank you for staying with us.
Thank you very much.
We wish you a happy week.
And to see you next week with a new random access memory. Stay frosty and safe.